Hello friends, this is a 2-mark question on computer networks on topic routing and congestion control. The question reads as follows. Consider the following network which uses distance vector routing from routing data. On each of the link the number represents a cost. Each router updates its table every 10 seconds. For a router 1, how much time would it take to convert the routing information? Assume that every router updates its table simultaneously and find out the minimum time required. And the options given are 40 seconds, 60 seconds, 30 seconds and 10 seconds. As we know, in distance vector routing protocol, each router maintains a vector of cost and next stop to all the destinations in the network. For example, router 1 would maintain distance vector of cost and next stop to router 2, 3, 4 and 5 in the network. Similarly, for all other routers. Initially, each router knows the cost to only its neighbor. For example, router 1 would only know the cost to reach router 2 and 4 and not router 3 and 5. So in distance vector routing protocol, we assume the cost to reach router 3 and 5 from router 1 is infinity. So at time t equal to 0, this is how the distance vector table for router 1 would look like. Similarly, for all other routers in the network. In distance vector routing protocol, each router shares its information about the network to its neighbor. For example, router 1 would receive distance vector from router 2 and 4 since they are the direct neighbors of router 1. Similarly for all other routers. So at time t equal to 10 seconds, router 1 would receive these two tables from the router 2 and 4. Using this information, router 1 updates its vector using the shortest path to reach the destination. For example, initial cost to reach router 3 was unknown in router 1, but using information from router 2 and router 4, it calculates the cost to reach router 3 as 35 via router 4. Similarly, for router 5, the cost to reach is 60 via router 4. Using same method, we calculate the updated distance vector table for all other routers. At time t is equal to 20, router 1 again receives distance vector routing table from router 2 and 4 and again updates its table to reflect the minimum or shortest path. For example, router 1 knows that to reach router 5 the minimum cost is 37 via router 4 since the router 4's distance vector is also updated at time t is equal to 10 seconds. This table gives shortest cost to all the destinations in the network from router 1. Now at time t is equal to 30 seconds, router 1 will again receive information from router 2 and 4. However, router 1 already has the shortest cost information to all the destinations in the network. Hence, router 1 converges and the correct answer to this question becomes C, that is 30 seconds.